Potentiometer is a device to produce a potential gradient. So we'll learn about potentiometer. So this is something to make a potential gradient. So what does it mean by potential gradient? Potential gradient, the actual meaning is a gradual change in potential. So, gradual change in potential. For example, we can get the potential from 0 to 3 volt, any value on a potential gradient. So it's a very simple arrangement. The most important thing is that it requires very few components. Primarily, you require a uniform wire. So it consists of a uniform wire. A potentiometer. A uniform wire, resistance wire, we can call it resistance wire. Is connected to a cell. That's the only thing you need to do. To a cell. So you can make it a little bit more elaborate, so you'll have better control over that. So this is the way it looks. So you will have a uniform wire. Okay, this straight line represents this uniform wire. This is the starting point of the wire. We call it P. This is the end point. Let us assume that here we have 0, here we have 100. So this is 100 centimeter long. It not necessarily be 100 centimeter long all the time. Some of the potentiometer wires are 1000 centimeter long. And the longer the potentiometer wire, the more sensitive the potentiometer becomes. So just to understand how does it function, you will just have a uniform wire of length 100 centimeter. Let us write the length of the wire as L. Now, how do we implement this potentiometer circuit? You connect from P to a constant DC power. You should always connect the starting point to the positive. That's just a convention. It's not compulsory, but by convention, the starting point of the potentiometer is always connected to positive terminals of cells. You may have a key to control the circuit, and you require a rheostat. This will help you control the current in the circuit, which we will call RH. I can write it somewhere here. Okay, let's write it here. RH stands for a rheostat. And you may also include an ammeter to measure the current in the circuit. And back to P. So this is called the primary circuit for a potentiometer. Now the potentiometer is ready. Primary circuit. So if you implement any potentiometer circuit, this is the primary circuit. So this primary circuit will enable a potential difference of V volt between P and Q. So you may write this within this L distance. You have a potential. This will be at a higher potential. So you will write it as plus, and then here will be the lower potential. The potential difference, we will write it as V. Now let us assume that the resistance of the whole potentiometer wire is R. R is the resistance of the potentiometer wire. Now, take any point in between P and Q. Let us call this point as A. And let us assume that from P to A, the distance is small l, and the resistance of this segment of the potentiometer wire, let us consider this as small letter r. So there are several relationships that comes in here. We will check them. Look at here. First thing we can write, the resistance of any segment of this wire is proportional to the length itself. If the total resistance is R, that would be proportional to the total length N. Now, because the current passing through this is a constant, this wire is a constant at every single point, we can always write the potential drop across any 2 points. Let us assume that the potential drop between these 2 points, P and A, as small letter v. What is small letter v? The potential difference between P and L. P and A, we will just write it as small letter v. Then we can just write the potential difference between any 2 points v is proportional to the length itself. Now, how do we get this relationship? It is very simple. The potential difference V is proportional to R. But from these relationships, we call it as 1, we get R upon R is equals to L upon N. So, R upon R is equals to L upon N. And this is an important relationship. And also we know that V upon V is equal to R upon R, that is equals to L upon capital L. So V, the potential drop between any 2 points in the potentiometer wire, is equal to, what will be that? Look at here, the V has gone to this side, so you will get L. So this quantity here, what you see here in this is called the potential gradient. So potential gradient is equal to the potential difference between the 2 ends of the potentiometer wire, V upon the length. So the unit of potential gradient is equals to volt centimeter inverse or volt meter inverse. Now, if you take sensitivity of the potentiometer, sensitivity is equal to, is usually taken as 1 upon potential gradient, that is L upon V. This is called sensitivity. The more the sensitivity of the potentiometer, the larger will be the potential difference between 2 points. Now, the smaller will be the potential difference between 2 points in a potentiometer. The more sensitive means you will have a smaller potential difference between any 2 points. But that means you will be able to get even small fractions of potential from the potentiometer. You will understand the importance of the sensitivity. Because when you can use a potentiometer, in fact, to measure the EMF of the cell. Unlike a voltmeter, when we use a potentiometer to measure the EMF of a cell, we get precise value because we don't draw any current. We will see that in our next lesson. So you can see that the sensitivity of the potentiometer is just, or you can even write equal to 1 upon or 1 over potential gradient. So you have several equations you need to keep in your mind. What are those equations? The resistance of the potentiometer wire and the length. That is one relationship. Then potential difference between 2 points and the length. That is the second relationship. Then finally we have the potential gradient. So let us put all these equations together at one point if you want. Where shall I put it? I will make a relationship table here. R is proportional to L, R is proportional to L, small v is proportional to R, capital V is proportional to R. Then potential gradient V upon L. Then we have one more sensitivity. Here I don't have enough place. I will write it here. Sensitivity is equals to 1 upon potential gradient. So we have all these various relationships that you can use in case of a potentiometer is put inside this little box. Now we will see in the next lesson how we can use a potentiometer to compare the EMF of two cells. Till then, goodbye and thank you very much for listening to this short lesson. Thank you.